So as we know, right, introduction to organic chemistry, there are 4 subtopics. Everything clear, right? Screen is clear, the sound is clear, right?
Yes.
Okay.
Yes, madam.
Okay, so let's start. So there are 4 subtopics. So molecular and structural formula, I think not a problem for you all. Functional group and homologous series, you have to memorize and identify what is the functional group and homologous series. Okay, so this one you have to put more effort to remember the structure and try to memorize the name of the functional group as well. Okay, part 3, I think most of the students will get confused for isomerism, but as long as you understand already, right, not a problem for you all to solve the question related with isomerism. And then question number 4 is reaction in organic compound. This one also no problem, so let's start. So this is the summary for 4.1. What do you need to know? First of all, you must know what is molecular, what is structural formula. Okay, for example, C2H6 is the molecular formula. The name of the molecular formula is ethane. So we can show this structure, right? Okay, in expanded structure, condensed structure, or skeletal structure. Of course, all the structural formula is in 2-dimensional formula. Show how the atom in a molecule are bonded to each other. So for example, this one, C2H6, you just know is 2C6 hydrogen, but you don't know how it bond together. So we can represent it by expanded. So you see, 1 carbon, 2 carbon, and then with 6 hydrogen. Okay, first of all, you must always remember, carbon must has 4 bonding. Okay, carbon must has 4 bonding. Every time when you draw the carbon, right, make sure there are 4 bonding for carbon and 1 bonding for hydrogen, 2 bonding for oxygen, 3 bonding for nitrogen. Okay, this is the basic concept. So if you were to explain what is expanded structure, indicate how atoms are attached to each other but are not represent of the actual shape of the molecule, just bonded, not the original shape. Okay, and then condensed, you have to show, okay, does not show single bond between carbon and hydrogen atom. That's why you can't see any bonding over here, but double and triple bond are shown. If there is about double or triple bond, means alkene or alkyne group there, right? You have to show the double or triple bond. And then all atoms that are attached to a carbon are written immediately after that carbon. So you see CH3, after that followed by CH3. Okay, and then skeletal, okay, is a very simple structure. Show only the carbon skeleton. Hydrogen atom are not shown. If other atoms such as oxygen, chlorine, nitrogen, etc. are shown. Okay, so you have to know, right? Actually, okay, this point represent 1 carbon, and then this point represent another carbon. Then there are 2 carbon. So this is C2H6 for skeletal structure. Okay, this is a simple structure. Later we can try a tutorial question for a more higher level structure to represent it. You must how to the conversion between expanded, condensed, skeletal structure based on the molecular formula. Interchange. The question might give you expanded and ask you to draw the condensed, or give you the condensed, ask you to draw the skeletal structure. Okay, next. Classification of carbon and hydrogen. You must classify carbon correctly, then only you can classify the hydrogen atom correctly, because the classification of hydrogen is based on carbon. Okay, let's start. Okay, so the first one, primary, attached or bonded to only 1 carbon. Tertiary, the carbon is attached to 2 carbon. Tertiary, attached to 3 carbon. And then quaternary, attached to 4 carbon. Okay, we look at this example. So let's check with this carbon. It attached to 1, 2, 3 carbon. So this carbon is tertiary carbon. Okay. Okay, let's check this one. If you look at this one, it attached to 1 carbon. So this one is primary carbon. Okay, if you look at this one, it attached to 1, 2. That's why this one is secondary carbon. Okay, let's find a tertiary carbon. Is there any tertiary carbon? Yes, this one is tertiary carbon. Because attached to 1, 2, 3 carbon. So this one is tertiary carbon. Automatically, right? Okay, this one is tertiary carbon. So, yeah, I change color. this hydrogen automatically is tertiary hydrogen because this one is tertiary carbon. So the hydrogen that attached to tertiary carbon is tertiary hydrogen. Okay, so for this one there is no hydrogen. This one no hydrogen because this one is 1, 2, 3. Okay, this one not quite tertiary. This one yes, tertiary. So this hydrogen is tertiary hydrogen as well. Okay, for this one, 1, 2, 3. For these 3 hydrogen is primary hydrogen. Why? Because this carbon is primary carbon. So clear? Any problem for the classification of carbon and hydrogen?
Clear, madam.
Okay, and then one important point. Look at this one. Okay, carbon-carbon double bond. We cannot classify carbon-carbon double bond because for the classification, right? After later you look in detail, right? It's only for sp3 carbon. What means by sp3? Tetrahedral. So means there are 3 single bond for the carbon. Okay, 3 single bond. 4 single bond. 4 single bond for the carbon 3. Okay, if the carbon not classified react in specific ways, which determine its chemical properties. Okay, means it has the same. If the molecule or the compound have the same functional group, right? They are having the same chemical properties. So it undergoes a set of chemical reaction. Okay. So homologous series is a series of compound where each member differ from the next member by a constant CH2 unit. If you watch through my video, right, I did explain, okay, how it different by CH2 unit. And then homologs is the members from the same homologous series. Okay, actually, right, this part is very simple. You have to know the name of the class of compound. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Consider 11, 12, 13, 14, 15, 16, 17. Okay, roughly around 15 to 17 of class of compound. And then you must know the structure. And then you must know the name of the functional group, the structure and the name of the functional group. And then here are the example of the class of compound. And then you need to identify. Okay, let's check one by one. Okay, alkene or cycloalkene, right? Alkana in Malay is. So there is no functional group for alkane. So just single bond, saturated carbon, carbon, single bond. Okay, when we proceed with alkene, the class of compound or the homologous series with alkene, the structure is C double bond C. The name is carbon double bond. So if I want to identify, yes, this one. This is the carbon double bond. Okay. I think red color better. Okay, then carbon triple bond. So this is a structure, and then the name carbon triple bond. So you have to circle it. When the question asks you to identify, this is the carbon triple bond. Next, aromatic compound. The class of compound or the homologous series is aromatic compound, and then with the structure like this, C6H6. Okay, for your information, right, the benzene, right, sometimes we'll draw like this. Okay, it's the same. The actual structure suppose is alternate double, single bond. Okay, and then we can represent the alternate double, single bond with a ring. Okay, so this is benzene ring. So if we identify, right, so you have to draw the benzene ring like this. So this is benzene ring. What is the homologous series or function or class of compound? Aromatic compound. Haloalkene we represent with X. X can be fluorine, chlorine, bromine, iodine. The name of the functional group is halogen, so circle chlorine. Okay, alcohol and phenol actually is with OH structure. Functional group still the same, hydroxyl. Just why I here differentiate to two, because phenol is referred to the structure. Okay, with this one. But when you identify, right, actually you no need to circle the benzene ring. Normally we just circle for the OH. Okay. Okay, maybe some of you might ask, oh madam, there is two functional group with benzene ring and hydroxy. Okay, depends. Okay, madam cannot say anything. Depends. Sometimes, but we know the whole structure is phenol. The whole structure is phenol. Okay, so when you circle this one is hydroxyl. Okay, this is a aliphatic alcohol, OH. Ether, COC, alkoxy. So COC, you just circle the COC. And then aldehyde, the difference aldehyde between ketone is aldehyde attached to H. So meaning that it at terminal. Normally aldehyde at terminal. And then ketone attached with two alkyl group. There is no H for ketone. So both of the class of compound under same function have the same functional group, carbonyl. So I will circle the CO. Okay, so CO, carbonyl. Carboxyl, okay, the class of compound is carboxylic acid, COOH. Ester, carboalkoxy. Okay, please take note. So there are C double bond O and then O. So you have to circle the whole thing. C double bond O, COC. COC double bond O. Okay. Be careful. When there is a C double bond O, you have to look at the left, right, up and down. Is there any other thing attached to it? For example, this is also the same. C double bond O, Cl, right? Okay, so this is alkyl. You cannot separate C double bond O as, okay, you cannot separate like this. C double bond O is carbonyl and then Cl is halogen. Cannot. So that's why I remind you all again, when there is a C double bond O, you check the left, right, up and down. Is there anything? Okay, so there is a O over here, COC double bond O, carboalkoxy ester. This one's C double bond O, Cl, acyl chloride. Okay, same for here. There are C double bond O, COC double bond O. So this one is anhydride under class of compound acid anhydride. Again, amide, C double bond ON. Okay, C double bond ON. So this is the whole structure over here is carboxylamide. And then amino is NH3, so you check this is NH3. And then the last one, nitrile compound, C that triple bond N, cyano group. Okay, so you circle over here. Okay, I think should be no problem for you to identify the structure and name the functional group. Okay, just don't be careless. Don't be careless. Okay, don't confuse between homologous series or class of compound with the functional group. Okay, madam ulang sekali lagi. Untuk 15 hingga 17 structure ni kan, okay, kita kena tahu perbezaan dia. Dan mengenal pasti. So, kat sini, class of compound, ataupun kita nama dia sebagai homologous series, ada nama dia. Ini nama dia. Okay, ini nama dia. Contohnya, you nak protein ke, you nak carbohydrate ke, you nak vitamin ke, ataupun lagi apa, fiber ke, semua dia ada nama dia. Tapi kalau kita pergi spesifik, okay, protein boleh dapat dari telur, dari daging, and so on. So, kita tahu struktur dan nama dia. So, kat sini kita panggil dia functional group. Okay, soalan biasa akan bagi satu contoh, suruh you identify. Contohnya kat sini. Identify the functional group. So, tengoklah. So, I think should be no problem for you all. Okay, so this one, for example, C double bond O, COC. So, this is, okay, you circle and then you point out. So, this is the functional group. What is the functional group? Write down the name. Anhydride. Okay, anhydride. Tulis . So, ni cara dia. So, you have to circle and then point out. Then name the functional group. Of course, you have to check because this question asks about functional group. Sometimes the question will ask to identify the functional group or class of compound homologous series. So you have to list out the answer in details. Okay. So I think that's all for 4.2. Any question?
No, madam.
No, madam.
Okay, so I try to test your understanding. I just random pick a. Okay. Am I correct if I circle like this? This is the one of the functional group. And then it's carbonyl. Am I correct? Look at the yellow color. I circle like this. And then I name it as carbonyl. Correct or not?
No.
Yes, no. Shah, fast respond. Okay, Amiru. Amiru, are you here? Amiru is not here. Okay, so actually you have to circle the whole thing here. Okay, I have to highlight the whole thing. C double bond O and H2. Okay, if you look at the list over here, which one is C double bond O and H here? So the functional group is carboxamide. Carboxamide. Here, spelling, please take note, carboxamide. Okay, and then this one, if I name this as ester, correct or not, class? The second one, look at this one, C double bond O COC. So I give the name as ester, correct or not?
No, madam.
No, cannot, because the question asks about functional group. So the name you have to give carboalkoxy. Clear? Okay, so next proceed. Wow. Isomerism 4.3. So you have to, based on here, you have to know that isomerism divide to two parts. Okay, one is structural or constitutional isomerism. Okay, first of all, what is isomer? Different compound that have same molecular formula. And the existence of different compound with the same molecular formula but different structural formula. Okay, maksudnya formula dia sama, tapi nanti you lukis, okay, struktur dia berbeza. So this one you call it as isomer. And then there are two. One is structural or constitutional isomer. Different compound with the same molecular formula but different in the order of attachment of atom. Cara susunan berbeza. Okay, if stereoisomerism, same molecular formula but different arrangement of atom in space. Susunan secara ruangan dia berbeza. Okay, so later we check what is the difference between structural and stereoisomerism. Okay, of course, under structural formula, there are three: change isomerism, positional isomerism, and functional group isomerism. So we have to know in details. Okay, change is differ in the carbon skeleton. Rantai dia berbeza. Change isomer is different carbon change. Have same functional group. Functional group dia tetap sama. And same homologous series, okay, under same family. But positional isomer is differ in the position of the functional group or substituent in the same carbon change. Ni rantai tetap sama, tapi kedudukan functional group berbeza. Jadi masih sama functional group, the functional group still the same, just change in position. And then functional group isomerism is, okay, so name is functional group isomerism, meaning it's different functional group and different homologous series, but with the same general formula. For this one, you have to take note, there are only 4 pairs. Okay, so it's alcohol with ether, aldehyde with ketone, carboxylic acid with ester, alkene with cycloalkane. Okay, and then when you want to draw the functional group isomerism, right, there is some rules and regulation. So for alcohol and ether, right, the N must greater than 1. Aldehyde, ketone, N equal or greater than 3. Carboxylic acid, ester, N is equal or greater than 2. Alkene and cycloalkene, the N must greater than 3 or equal to 3. Okay, so this is the basic introduction for structural isomerism. Okay, for stereoisomerism, there are 2. One is diastereomer. Okay, the diastereomer, right? There are two. Okay, normally we just look at the one, Cistron Isomer or geometrical isomer. Normally, when the question asks you to draw the diastereomer, Cistron Isomer, geometrical isomer, actually it's referred to the same thing. So differ by group being on the same side, we call it as cis isomer. If opposite side, we call it as trans isomer of a site of rigidity in a molecule. Okay, when you study about stereoisomerism, right, there are some rules and regulation. So for diastereomer, right, first, restricted rotation about carbon-carbon double bond in alkene or a carbon-carbon single bond in alkane, but must in cyclic compound. Number two, each carbon atom of a site of restricted rotation has two different groups attached to it. So these are the two requirements for geometrical isomer. Kalau you nak lukis Cistron isomer ataupun geometrical isomer ataupun diastereomer memerlukan benda yang sama, dia mesti memenuhi dua syarat. Syarat pertama mesti alkene ataupun cycloalkane. Syarat kedua, semasa you lukiskan, setiap carbon tu atas, bawah, kanan, kiri dia mesti berbeza, tak boleh sama. Kalau sama, walaupun dia alkene ataupun cycloalkane pun tak jadi. Yeah. Okay, and then second one, enantiomer. Enantiomer is a pair of stereoisomer which are mirror image, macam pantolan cermin of each other but are not superimposable. Okay, so if you look at my video, right, I did tell you what is superimposable. Okay, if you take out your hand, right, your both hand, you want to, okay, if you cover, okay, your both hand, right, impossible that will be attached, can be matched exactly. Okay, tak boleh tak boleh bertindih dengan tepat. So this one is not superimposable. Okay, as of course, still the same. There are requirements for the enantiomer. Must has chiral carbon. If you look at what is chiral carbon, it's a sp3, again, sp3 hybrid carbon with 4 different groups attached to it. And it is not superimposable with its mirror image. Mirror image is pantolan je, not so it's not different with the superimposable term. Okay. Let's look at some example about isomerism. Okay, so this one is change isomer, all with C5H12. Okay, but you check, this is straight change. This one is pentane. This one with 1 branch butane, and then this one with 2 branch propane. But when you check, all are C5H12. Okay, this is change isomer. Okay, positional isomer. Okay, if positional isomer, you check. Look at this one. Oh, the change still the same. Okay, the change still propane. This one also the same. The change still propane. But the difference here, right, is this. Okay, the difference here is this. The Cl. This Cl at the position number 1. But this Cl at position number 2. So this one we call as positional isomer. Same for here. The carbon-carbon double bond, C1, C2. But for this one, C2, C3. But the change still the same, C4. But the position of the carbon-carbon double bond different, C1, C2. This one C2, C3. So we call it as positional isomer. Okay, this one a positional isomer as well. Okay, not necessary functional group. If the one group of the substance, right, change position, also consider as positional isomer. Okay, same. Okay, functional group isomer that I mentioned, there are 4 pairs. So you look at here. This is alcohol. This one is alcohol. This one is alcohol, OH. And then this one, COC. Okay, both have the same molecular formula, but this one is alcohol, this one is dimethyl ether, means ether. Ether, alcohol, hydroxyl, alkoxy. Okay, aldehyde, this one C double bond OH, this one COC, C double bond O at the middle of the structure. Okay, carboxylic acid with ester. Okay, then we go for Cistron Isomer. Okay, look at this one example with carbon-carbon double bond. Wait, I cannot adjust here. Okay. Okay, again. So this one Cistron, why Cistron? This one C double bond C. Okay, this one also Cistron, C double bond C, and then okay, the group over here, the similar group is at different side, so it's trans. This one, the similar side, the similar compound at the same side, so this is cis. Okay, cyclic compound, cyclohexane. Okay, so same side, so this one is same. Cis. So this one has different side, so this one is trans. So any question for the geometrical isomer? Must have 2 different group. What means by 2 different group? You see, this one is CH3, this one is hydrogen, different group. Hydrogen, CH3, different group. Both sides must have different group and then must be cyclic compound or alkene that only can consider as geometrical isomer. Okay, if same compound H, even though this is carbon-carbon double bond, but have the same atom or same molecule, so this is not Cistron isomer. Okay, we have to know the properties of the Cistron isomer. They are different in melting and boiling point. For cis isomer, polar compound. Trans isomer, non-polar compound. Okay, that's why the melting point for trans is higher than cis isomer and the boiling point for cis isomer is higher than trans isomer. Stability is trans more stable than cis isomer. So you have to know how to explain. Okay, now we go for the enantiomer. Enantiomer, okay, the important point is over here, must have chiral carbon and so not superimposable with its mirror image. If you're not sure what is chiral carbon, look at here, sp3 hybridized carbon with 4 different groups attached to it. So now we check the details. So this is the example. This carbon, okay, sp3 must be sp3. sp2 means carbon-carbon double bond or triple bond cannot be classified and cannot be enantiomer as well. So this is A, B, C, D, all different group. Okay, so for example, okay, this one compound might be more than 1 chiral carbon. That's why you have to check each single carbon. First must be sp3, second must attach to 4 different groups. Okay, over here there's only 1 chiral carbon. This one cannot because H3. This one also cannot. H2. This one H3 is attached with the same atom, cannot. Only this one is chiral carbon because it attached with, first it's attached with chlorine. Then it attached with CH3. Then it attached with hydrogen. And then it attached with CH2, CH3. So 4 different groups attached to it. Okay, clear? Others example also the same, 4 different groups. Okay, hydrogen, hydroxyl, CH3, COOH. CH3, OH, and then hydrogen here, and then the big group over here attached to 4 different groups. Bromine, cyclopentane, hydrogen, and then CH3, 4 different groups. So that's why these all are the compounded with 1 chiral carbon. Okay. So after that, right? After you know the chiral carbon, next we have to draw the enantiomer. So in enantiomer just a reflection, okay, but not super impossible with its mirror image. Reflection, this is like mirror image, so we have to draw a mirror over here and name it as enantiomer. Okay, Okay, any question? So this is isomerism. Ada soalan?
No.
Okay, so race mix just a term for you all. You must know, just you have to know what is race mix, that's all. Equimolar mixture of enantiomer which is optically inactive, but because the 2 components rotate plane polarized light equally. Okay, this is nothing special for race mix. Okay, now we proceed for the last part. Before I proceed, I check how many of you. Okay, 21 minus 2, 19. Who is not here? Why the attendance just only 2? Siapa boleh beritahu saya siapa tak ada kat sini? Jason, who is not here? Please help me check. Shah, please help me check who is not here. Okay. Okay, we stop a while first. Okay, before we proceed to the last part. Okay, while we proceed to the last part, right, you take out your tutorial. We straight away discuss 4.4. We straight away discuss tutorial. Okay, keluarkan tutorial. Untuk 4.4 kita boleh terus jawab. Terus bincang. Okay, if you check for the tutorial, right, question 1 is about the expanded, condensed, and skeletal structure. Okay, so define structural formula, draw condensed structure. This one is skeletal. This question is skeletal question and ask you to draw the condensed. And then this is condensed and then ask you to draw the skeletal structure. And then question 2, explain functional group and homologous series. And then the molecular formula is given and then ask you to draw the structural formula. Then identify and name the functional group. Okay, so there are only 2 questions for functional group. Okay, from question 4 until question number 10. Okay, question 4 until question number 10 all are about isomerism. Okay, question number 11. Explain the difference between homolytic cleavage and heterolytic cleavage. Then give 1 example for each cleavage. So this is a fact question. I think should be no problem as long as the lecture notes is with you all. You can answer this question. But the problem is, do you understand what is homolytic cleavage or heterolytic cleavage? Okay, number 12. Define electrophile. and then define nucleophile. Then classify. So you must know the tips how to identify the electrophile and nucleophile. Okay, and free radical as well. Question number 13. Arrange the following carbocation in the order of increasing stability. Of course, you must know how to classify the carbocation first, then only can arrange. Okay. Question 14. Identify nucleophile and electrophile. So just now it's in general, straight away ask you to identify. But over here, right, there is one equation is given and they ask you to identify. Student might randomly give the answer. Maybe they can think, this, for example, this is A, this one is B, this one is C, this one is D. For your information, right, if you want to identify the nucleophile and electrophile, you just can identify based on the reactant. So you have to choose from these two choices. Okay, and then state the type of reaction. And question 15, identify the type of reaction. Same for question 16, identify the type of reaction. So you must know how to identify the type of reaction. So are you ready?
Yes, madam.
So now we go for last part now. Wait, Izati. Okay, thank you. Here, everybody please take out your tutorial. Please take out your tutorial. Okay. We are cover tutorial 4.4 as well. Okay. So first, 4.4, covalent bond cleavage. So there are two. The first one is homolytic cleavage. What means by homolytic cleavage? Homo. If the concept same as bio, homogeneous, heterogeneous. Okay, it's the same. Okay. So for homolytic cleavage is non-polar bond, similar electronegativity, break symmetrically, and after it break, right, it will divide to two equal parts. One unpaired electron form, and then the unpaired electron form we call as free radical. Okay, the key point for this type of reaction is with UV, HV-UV, ultraviolet. Okay, ultraviolet is provide the energy to for the free radical happen. Okay, for the homolytic cleavage happen to form the free radical. So, okay, when it break, right? Please take note. For homolytic cleavage, half arrow. This is the only equation with half arrow. Okay, semasa buat equation ni kan, untuk membentukkan free radical mesti ada UV. Kerana UV ini memberi atau membekalkan energi supaya homolytic cleavage berlaku untuk membentuk free radical. So, lepas dia pecah, dia membentukkan dua free radical. Okay, heterolytic cleavage, okay, is opposite of homolytic cleavage. Polar bond, different electronegativity, break unsymmetrical. And then when it break, right, okay, it will form the cation and anion. And then the electron will move to the atom that more electronegative. Okay, so for example, if the A is more electronegative, so the electron will transfer to A will become the anion, and then B automatically will become the cation. If the C is more electronegative, so C will become the anion and the A will become the cation. Okay, so that's all for homolytic and heterolytic cleavage. So we answer question number 11 already. Okay, now now next point is you must know the stability of carbocation, carbanion, and free radical. Okay, the concept for carbocation and free radical is the same. Okay, carbocation, the positive carbon, and the free radical, the concept is the same. Okay, when the class of the carbocation and the class of the free radical increase, it will be more stable. So for example, tertiary carbocation or tertiary free radical is more stable compared to methyl cation or methyl free radical or methyl cation. So but right here I have to label as methyl free radical, not methyl cation. And then carbanion stability is reverse, meaning that tertiary carbanion is the least stable, and then the methyl anion is the most stable one. This is affected by inductive effect due to the EDG, electron donating group, which is alkyl group. Alkyl group can stabilize the carbocation and stabilize the free radical, but destabilize the carbo anion. Okay, if you check a tutorial, there are explanation. Next, we go for electrophile, nucleophile, and then Lewis acid, Lewis base. These are the definition you should know. Electrophile, electron deficiency species. Okay, maksudnya dia tak cukup electron. So normally the E, right, will represent like this with the positive charge. And then the nucleophile, of course, is opposite of electrophile. So normally with lone pair, suppose I draw like this, lone pair, dot, dot with the negative charge. So neutral or highly negative because it's rich in electron pair. For example, the water, H2O with 2 lone pair, ammonia with 2 lone pair. That's why nucleophile, right, normally is Lewis base, donate a pair of electron. And then for the electrophile, normally is Lewis acid. Okay, it's the compound that can accept a pair of electron. Why it can accept a pair of electron? If you still remember chapter 4, incomplete octet. Okay, that's why it can accept, for example, BF3, BF3, AlCl3, okay, all under here. Okay, by right, I have to explain the electrophilic side and nucleophilic side, but never mind, you just based on this understanding, you can solve many problems. Addition. You must have the concept, what is addition? Double bond becomes single bond. Double bond become single bond. Okay, substitution. Replace the hydrogen replaced by the chlorine. Initially is CH3, now becomes CH2Cl. Replace. Okay, this is benzene. They are hydrogen. Okay, and then the hydrogen is replaced by the bromine molecule, so it's substitution. Okay, Br substitute by OH, substitution. Okay, and then elimination is from single bond become multiple bond, double bond. Okay, rearrangement, the structure still the same. Yes, C double bond C. Okay, here also C double bond, but it's C double bond O, means rearrange already the structure. Okay, over here, right, for addition, you have to be specific. You have to identify is nucleophilic addition or electrophilic addition. And then for substitution, you have to identify nucleophilic substitution or electrophilic substitution or free radical substitution. Okay, I give you some clue. For the free radical substitution, very simple. With UV. As long as the equation with UV, ultraviolet, okay, that one is free radical substitution. Okay, how are you going to identify the nucleophilic addition, electrophilic addition, nucleophilic substitution, or electrophilic substitution? Okay, this one you have to refer the lecture notes in details. Okay, normally, right, I will ask my student to identify the site. Okay. Okay, nucleophilic site means the site with high electron density. Okay, with high electron density. Like carbon-carbon double bond, carbon-carbon triple bond, or benzene ring. So this is high electron density area. So it's nucleophilic site. Okay. Then this one C double bond O, CX, COH, the carbon is partially positive. So and then this one is electrophilic site. Okay, since you know the site already, right? How to identify the site, right? Okay, we can know the type of substitution or addition. Okay, when an equation is given, okay, we check. This is carbon-carbon double bond. So this one is nucleophilic site. We give the name electrophilic addition is based on the electrophile. Apa yang ditambah, apa yang ditukarkan di, itulah nama dia. So this one is electrophile added. That's why it's electrophilic addition. But I want to ask you all, can you identify bromine is the electrophile? Boleh tak you terus nampak bromine je lah electrophile means low electron density. Okay, jadi dia lebih positif. Cannot, right? But you can identify the site. Site is easier. Double bond, carbon-carbon triple bond, benzene ring, nucleophilic site. Automatically electrophile is added. Okay. Same for here. C double bond O. New electrophilic site. Okay, so nucleophile. Based on here, HCN you check actually is neutral. You're not sure is electrophile or nucleophile, but CN actually is with negative charge. So it's a nucleophile. So nucleophile is added over here. That's why it's nucleophilic addition. Jadi Madam akan galakkan you identify the site. Kalau you dapat identify the site, automatically you tahu partner dia ialah nucleophile ke electrophile. Jadi memberi nama berdasarkan partner dia. Partner yang masukkan atau partner yang tukar ganti. Okay, so substitution is same concept. As I say just now, if there is a UV, free radical substitution. Okay, this is benzene ring. Benzene ring is nucleophilic site because high electron density. So bromine automatically is electrophile. So electrophile is substitute. But take note, since this one is benzene ring, the name is special. Electrophilic aromatic substitution. Okay, the H is replaced by bromine. Kalau ada benzene ring, kena ada perkataan aromatic. Okay, nucleophile, okay, like here, CX. So this carbon is partially positive, so it's electrophilic site. Okay, nucleophile is added. For this case, it's simple because there is a negative over here. Yes, automatically you know this is nucleophile. With negative charge, automatically it's nucleophile, so it's nucleophilic substitution. Clear? Okay, that's all for chapter 4. Now let's try tutorial question. Okay, I give you around 5 minutes. Okay, I give you around 5 minutes to check. Let's do question number 14 first. Question 14. Okay, semua orang Madam bagi 5 minit tengok tutorial 14, 15, 16. Okay, try to identify the type of reaction and then identify the nucleophile, electrophile. Or same for question number. Okay, let's go for this one. This one simple. Question number 12B. 12B dulu . Okay, question 12B, right? The first one, ammonia. Ammonia with lone pair. NH3 with lone pair. If lone pair, right, meaning that it's Lewis base. So Lewis base is nucleophile or electrophile?
Nucleophile.
Yes, very good. Okay, bromine. There's a dot. So this one is?
Free radical.
Yes, free radical. Yes, free radical. Very good. H2O. Just now I did mention this one. Okay. H2O. There are two lone pair. So nucleophile or electrophile?
Nucleophile.
Yes, nucleophile. Positive charge. No need to think twice. What is it?
Electrophile.
Yes, electrophile. Negative charge.
Nucleophile. Nucleophile.
Yes, nucleophile. Positive charge.
Electrophile.
Yes, electrophile. BF3. I did mention this is Lewis acid. Lewis acid incomplete. Yes, electrophile. CO2. CO2, the answer is can be electrophile, can be nucleophile. Up to you. Depends on you whether you check for the C or O. If C, electrophile. If you look at the O, is nucleophile. Okay, Same for CH3OH. CH3OH also both can be nucleophile or electrophile. If you look at the C, is electrophile. If you look at the O, is nucleophile. Faham tak? Kita kena tengok kerana CO2 kan dia ada C ada O. C tu electron density dia kurang. partially positive. That's why dia ialah electrophile. Tapi kita tengok O partially negative. Jadi O je lah nucleophile. Sometimes dia lah melipatkan O juga. Same for CH3, OH. Okay, double bond, multiple bond. Multiple bond jadi ialah apa? CC multiple bond. Carbon-carbon double bond. Nucleophilic site. So this is nucleophile. PCl5. Expanded octet. Expanded more than 4 means high electron. So this is nucleophile as well. Any question to identify the electrophile, nucleophile, and free radical?
No, madam.
Okay, semua ikut lah. Okay, next. Okay. OH negative, nucleophile, electrophile?
Nucleophile.
Nucleophile.
Yes, nucleophile, and then Cl is replaced with the nucleophile. So what type of reaction?
Nucleophilic.
Yes, nucleophilic what? Nucleophilic what? Addition or substitution? Have to be specific.
Substitution.
Yes, nucleophilic substitution. So again, identify the nucleophile and electrophile. Have to look at the electron. Look at the reactant. So the nucleophile is hydroxide. Okay, and then the electrophile is the CH3Cl. Yeah. Okay, now we look at question 15. Do you notice? So what type of reaction?
Aromatic substitution.
No. Don't be too excited. When there is an aromatic and then you tell me this one is aromatic substitution. The aromatic substitution must happen inside the ring. But this one is outside the ring.
Substitution.
What type of substitution? Okay, for your information, substitution and addition, you cannot simply answer substitution or addition. You have to tell me the type. Nucleophilic, electrophilic, or free radical. If you just simply give the addition or substitution, the answer still is wrong. Look at here. Okay, very good. Yes, nucleophilic substitution. Why? Because here is electrophilic site. The C double bond O is electrophilic site. Nucleophile is substituted. So nucleophilic substitution. How about this one? Double bond becomes single bond. Okay, I would like to ask, right, later, do you all got class or not? 9 o'clock got class or not?
No, madam.
Okay, no, then good. We continue until discuss all the question. Okay, carbon-carbon double bond. So what is the site? Electrophilic or nucleophilic site?
Nucleophilic.
Nucleophilic site, right? So this one is electrophile or nucleophile?
Electrophile.
Electrophile. So what is the name?
Electrophilic addition.
Yes, electrophilic addition. Electrophilic addition. So just now this one is nucleophilic substitution. So this one is nucleophilic substitution. Okay, how about C? C, double bond becomes single bond.
Elimination.
Yes, elimination. Very good. D? Yeah, the double bond becomes single bond. No, is it elimination, C? No. This is double bond becomes single bond. Okay, D is elimination. D is elimination. Look at C again. C is double bond becomes single bond. This one confirm is addition. But what type of addition?
Electrophile.
Yeah, electrophile is added. Yes, electrophilic addition. Electrophilic addition. Okay. UV. Finally, there's a question about UV. UV is?
Radical.
Yes. Cannot answer free radical only. Must answer free radical substitution. Free radical substitution. Okay. This is benzene. And then the H is replaced by NO2. So what is the answer for F?
Aromatic substitution.
Wrong.
Substitution.
You must put the word electrophilic. Aromatic substitution. Okay. You have to answer incomplete. Mesti ada perkataan electrophilic, mesti ada perkataan aromatic, and then substitution. Okay. G. Okay. G single become double. What's the answer for?
Elimination.
Yes, elimination. So G is elimination. Okay, so I think should be no problem for you identify the type of reaction. Madam ulang sekali ya. Okay, ni OH replaced by Cl. Kita tahu dia substitution. Tapi substitution tak akan betul. You kena beritahu dia nucleophilic ke, electrophilic ke. So tengok macam mana. Kita tengok ni. C double bond side dia. C partially positive. Okay, partially positive. Jadi nucleophile akan masuk tukar ganti. That's why nucleophilic substitution. Ni carbon-carbon double bond. Nucleophilic side. Jadi double bond jadi single bond. Double bond jadi single bond. Ada record ke tak? Lupa record. Okay, double bond jadi single. Baru lah. Okay, biar je lah. Okay, so double bond becomes single bond. So it's addition. And then this is nucleophilic side. So electrophile is added. So that's why electrophilic addition. Same for here, carbon-carbon double bond. So electrophilic addition. So single become double, elimination. Same for here, single bond become double bond, elimination. Okay, with UV free radical substitution, benzene ring, the H is replaced by NO2, so electrophilic aromatic substitution because the benzene ring is nucleophilic side. Okay, how about question 16? What is the A? Simple.
Free radical
Substitution.
Yes, correct. How about B? Single bond become double bond.
elimination.
Yes, the last one. Double bond becomes single bond, addition. So what type of addition? Carbon-carbon double bond, nucleophilic side.
Electrophilic
Yes,
addition.
yes, electrophilic addition. Very good. Okay, so you double check again, question 16, 15, 14, and question 12. Check, any problem? Okay, question 11, I think no problem. Okay, 11, no problem, I won't discuss. Just explain the difference. Just I did tell you the difference already, and then give the example. Okay, question 13. Okay, I random call somebody. Christina. Okay, nampak cursor, madam. What class of carbocation? There are 4 carbocation over here. So what class of carbocation for the first, second, third, and fourth? The first one? Christina, are you here?
Yes, madam. Wait, madam. I confused.
Okay, jangan confuse. You tengok carbon ni. Ikat dengan berapa carbon?
2 carbon. 1 carbon.
So, primary.
Oh, primary.
Okay, yang ini ikat dengan berapa carbon?
Here.
Sorry, tak dengar. Berapa? 1, 2, 3 dulu. Third, 3. 3 jadi maksudnya?
Tertiary.
Tertiary. Okay, yang ini? Ni tak ada kan? Tak ada, kita pakai methyl lah. Okay, yang ini?
Yang itu 2. So
Yes,
secondary.
Okay, so first step, you have to identify the class of carbocation. Okay, semua orang kena buat macam tu ah. So, yang first ini primary, kemudian yang ini ialah tertiary, yang ini ialah methyl, kemudian yang last sekali ialah secondary. Okay, tadi tak tahu kan yang mana paling stabil sekali?
Tertiary.
Yes, tertiary paling stabil. Jadi sekarang you kena tengok urutan dia. Dia nak 1, 2, 3 ke 3, 2, 1? Arrange the following carbocation in order of increasing stability. Maksudnya dia nak 1, 2, 3 lah, faham? Okay. Jadi semasa you buat susunan, okay, kalau I bagi ini sebagai A, you boleh label tapi you have to make the statement first, okay? Assume that this one is A, this one is B, this one is D, yeah? So the arrangement should be, which one first?
C, A, D, B.
C,
A,
A, B, B ke? B ke D?
D.
D.
B, okay, and then B. Okay, yes, very good. So this is the arrangement. So this is the arrangement. And then of course you have to put an arrow and then showing that this one increasing of stability. Mau pejat, dia lari sikit. Okay, think. Okay, CADB increasing of stability. Okay, if I continue extend this question, explain. Okay, jadi nak explain macam mana? Okay, this is the explanation. The alkyl group is electron donating group, which can stabilize the positive charge on the carbocation. So the stability of carbocation increase with the number of alkyl group. Okay, the alkyl group can represent with R, the symbol R present. So this is the explanation. Please jot down. Soalan ni madam nak explain. So this is the explanation. Okay. Alkyl group macam mana? Kalau siapa yang tak tahu apa lagi tu alkyl group kan, madam tunjuk sekali lagi. Okay, ni alkyl group. Ni R tu alkyl group. Contohnya, ada contoh yang bagus ke? Ni semua general. I tahu ada satu contoh kat belakang. Nampak tak? So ni alkyl group dia. Ni alkyl group. Ni pun alkyl group. Kalau ada benzin pun alkyl group. Semuanya tak mestinya CH3. CH2, CH3 pun boleh ya. Satu cyclic macam ni kalau attach pun boleh jadi alkyl group. Anything with CH itu semua adalah alkyl group. Okay, that's all for today. Any question?
No, madam.
Okay, so meaning that madam already covered from question 11 until question 16. Okay, so this Wednesday we are going to discuss question 1 until question 10. Okay, we are going to discuss question 1 until question 10. And we are going to have a test for chapter 1, 2, 3 as well. Please study. Okay. Let me check. Okay, question number 8. I want to give you the answer. Straight away, I give you the answer. Question number 8. Okay, everybody, please jot down. Because question 8 is related with explanation. Okay, draw, I will skip first. I want you all to look at 8B. Suggest which of the isomer has higher boiling point or higher melting point. Meaning that this one is related with cis and trans. If you refer to my video, right, I did explain about this. Okay, you can check. So this is the answer for comparison of melting point and boiling point for cis trans. So cis higher boiling point. Polar. Due to its polar, right? Okay, of course, trans is non-polar. So the polar compound has stronger van der Waals forces, means the dipole-dipole forces. That's why higher boiling point. And then melting point, trans is higher. Why? Because the molecule has more closely packed, because zigzag. Okay, means this is a heavy group, this is a lighter group. Okay, they can arrange closely. That's why the melting point higher if you want to break the bond. Okay. From a solid become liquid. Okay, these are the reason. Comparison between melting point and boiling point for cis and trans isomer. Jot down. So this is for cis isomer, higher boiling point. Trans isomer, higher melting point. And the reason. Okay. The structure is trans 1,2-dichloroethane. Let me check. Yeah, okay. AB discussed already. Okay. Okay, that's all for today. So today for around one hour 10 minutes our class. So we cover already chapter 4. Okay, please try for the isomerism. I think if you can try complete your tutorial, should be no problem to identify the type of isomerism. Okay, bye. See you on next this Wednesday. This Wednesday, 2 to 4. Face to face, our first face to face class. Okay. If no question, let me check the attendance again. Yes, 21 of you. Minus 2 is equal to 19. You see, just show shy and madam. Okay, never mind. Okay, since I know it's Atika, right? Atira or Atika, Jason? Oh, sorry. Okay, Izati. Okay, Izati. Okay, Izati. Yeah. Okay, that's all for today. See you all on Wednesday. Bye.
Thank you,
madam.
Thank you, madam.
Thank you, madam. Thank you, madam.
Thank you, madam.